We're here in Lincoln University today to talk about soils and some of the intricacies of soil structure and the way that interacts with soil moisture. So we're going to look at the way soils are made up, what the components are, and then we'll talk about where the water resides in the soil profile in relation to the plant roots. So soil's made up of a lot of components. We've got our sediments and we've got a lot of organic material, plant roots and other organisms. So most of the sediment is sand or silt or clay, and we're going to talk about how that produces a texture in the soil that gives it some open space for the water to move through. So those open spaces are called pores, and we have macropores and micropores. And as you'd expect, macropores are the large openings in the soil and the micropores are very, very small. And those pores have different functions in terms of the flow of water through the soil profile. The combination of sand, silt and clay in the soil is unique to the location. This particular soil here in Lincoln is quite a juvenile, undeveloped soil, a Templeton sandy loam. And so from its name, we understand how much of each of those particles is present, mostly sand in this particular soil profile. And the macropores that are developed are the ones that readily fill with water when there's an irrigation event or a large rainfall event, but they also freely drain soon after that water's been applied. And what's left is spaces for air and oxygen to enter the soil, and that's really important for root growth. The micropores are very, very small pores within the soil that hold water, and they're the ones that hold water against the tension of gravity. And they're really important because that's where the plant accesses the water it needs to grow. So we can tell a lot about the soil or the texture of the soil by looking at the layers, which is why we're in a soil pit. And it's really important to understand your soil to quite a depth below just the bit that you're probably used to where the plants are growing right at the surface. So in this particular soil we can see several colour layers occur simply because of the distribution of those particles over time. So in the top we've got quite a nice rich brown colour, and that extends about 200 millimetres from the surface. And then there's other colour layers that occur 400, 600 and even right down to 800, and we get some really rich clay colours further down. And each of those layers has a different characteristics in terms of the way the water is held in the soil and flows through. So the other characteristic of soil is its structure. So we talked about texture in terms of the soil particles, but structure is also important. And structure is often around the columns of soil and the layers and the cracks that appear through the soil. And in this particular location you can see some quite deep cracks penetrate down through the different profiles. And then further down we've got some layers that are quite dense in terms of penetration of roots, would be controlled at quite a low level. And you'll be able to see down here the roots penetrate quite a long way through the soil, down almost to 800 millimetres below the surface. So understanding that entire depth is really important in terms of soil moisture management. It's not just about the top 100 millimetres or 200 millimetres.